Now, if I want to graph sine x minus pi, what you should notice is we first need to graph sine lightly, and then we're going to shift it pi over horizontally. And it's always opposite, so this is going to be to the right pi. So, but let's first, what we're going to do first, again, what we're going to do is we're going to just simply graph y equals sine x. We're going to graph that. And then we're going to shift it. But we're not going to graph it completely. If you think about sine, what you should know, sine graph starts right here. All right, and what's the amplitude of sine? Actually, let's start over real quick. Not start over, but let's get these real quick. That'll help. For a sine graph, this one's just going to be shifted. What is the midline of this one? Well, has it been moved up or down? No. So wouldn't your midline simply be y equals 0? And your amplitude, what's the amplitude? Well, there is no change. So what's the normal amplitude of a sine graph? 1. Okay. No change. There was no number to affect it. So it's 1. And what's your normal period? Because the period hasn't been affected by this graph. The normal period is one time around the unit circle, which is 2 pi. Sinusoidal graphs are all 2 pi because it's one time around the unit circle, repeats, and it's done. So I got that. Now, what you need to realize is, let's just put a 1 here and a 1 here. Is that okay if we label these real quick? That's our amplitudes. So what I mean by that is, for sine graph, doesn't sine start there? And then won't it go up to the amplitude of -1, positive 1, sorry. So right here, won't it go up to there, and then it come back down to pi? If you look at what sine looks like, it kind of goes up, back down, and then it goes down to -1 and back. Any questions? That's what sine kind of looks like. Do we need to put more dots? Well, you could. If you want to put a couple more just to get you a flavor of what's going. But you don't want to put it too much because this is going to be moved. You don't want to make it too much information. Now, can I also make this to the left side? Can you keep the pattern going, hopefully? Can you see this graph would go down to here, up to here, and up to here, and back down to there, and you kind of have this graph that kind of looks like that. So you can kind of see it right there, but that's not the final answer. We're going to take that red graph and shift it, what? We're going to go right, is that correct? Positive? Right pi units. So it might be good to even write that down. We're going to write pi units. So can we take several of these dots and move pi and see what happens? So I'm going to take this dot right here. If I move it pi units over, are you okay? It's going to be right there. Some of you, it's a little hard, but you can hopefully see pi units would be right there. So if I take this dot and move it over, it's now going to be right there. If I take this one, can I move it pi over and go right there? You see, I'm just taking my normal units and moving them pi to the right. Not all units do we have to move. Once we get enough, we can see what that looks like and sketch it. Okay, now these right here, okay, what happens when you move this one pi units over? Boop. Do you see how it just lands on the other one? If I move this over pi, isn't it right there? Okay, those are kind of on top of each other. All right, so won't these just become blue now? Do you see how no matter where we are, isn't this one going to move over to here? Isn't this one going to move over to here? So do you see the blue graph kind of coming, hopefully? Where's this guy going to go? Isn't he going to go to the right pi? Isn't this, oh, that guy's going to go off the graph, isn't he? He's going off, so I can't really do him or her or whatever you want to call it. So can we put that right there? Can you kind of start seeing the graph? Can you kind of start seeing a sine graph that's been moved a little bit? There it is. Now, how do you get that last little piece on the left side? Well, can you kind of predict it? Because you don't have values to the left that moved. You kind of got to do some predictions. And hopefully you can predict it looks like that to finish it off. And that would be, the blue is sine x minus pi. The red is just sine x. The blue is now our shifted new version. Now for g of x here, we have a 3 in front of cosine x. So hopefully you know that 3 means you're going to vertically stretch it 3 units. Let's first find our magnitude, our midline, amplitude, and period. So our midline, will it change? If we're stretching it, will it change? No. It should still be y equals 0. But our amplitude, if you're stretching this vertically, do you see our amplitude is going to change? This is where it's changing. This is now going to be a 3. Does your period change when you stretch it up? No. It's still going to be a 2 pi period. There's no period change. So you can tell, like, this is your normal. This one just had an amplitude change. Because the reason we're saying those is it asks for them right here, just in case you forgot or didn't realize. It says right there what you want. That will also help us with graphing this. So if I'm going to graph this, I first want to think, what does cosine look like? Now cosine normally would start at 1 right here. But since this is an amplitude of 3, where are we going to start? Instead of at 1, can I just maybe put a line up here and call it 3? So can I simply go 1, 2, 3, and that's now where I'm going to start. So, and cosine normally started at 1, but can I now just start at 3 because I multiplied it by 3. Now your next dot for cosine, don't you have a dot right there for cosine? If you look at your normal cosine graph. Now what happens if you multiply 0 times 3? Does that move? No. So that one's going to stay right there. If that 0 value won't stretch, it's right, boom, it stays. Your next value for cosine was negative 1. Now can I multiply that by negative 3, by 3? Won't that stretch down to here? So your cosine dot goes right there. Then it kind of cycles back up, and then your last dot right here was at 1, but now it's going to be up here at 3. We don't make it dotted because this is actually the graph. I just stretched a cosine graph by 3. That was, cosines look like that, stretched by a factor of 3. Now, can you do the same graph on the left side? Keep it going. That's the key. Some people struggle with trying to replicate it, but hopefully you can see it kind of looks like this, and then it goes down to here, back up, and there's my graph. Now for some of you who want to see the regular cosine graph, I'm going to quickly do a light sketch of it so you can see what the regular cosine graph, so you can see the stretch. Regular cosine would have looked like this. See that right there? That little blue graph right here is what regular cosine looked like. Do you see how the red is a stretched amplitude of 3 of that? So you don't have to draw that in unless you want to see what happened. I want the midline, amplitude, and period of this tangent graph. Tangent's different than sines and cosines. And this negative 2 in front is going to do something to tangent. Hopefully you realize that negative 2 is going to push it down 2 units. So let's first talk about just tangent x. Your midline, well, if I pushed it down, it normally is at y equals 0. But if I pushed it down 2 units, my midline is now y equals negative 2. My amplitude, well, is there an amplitude to tangent? Is there a highest and lowest point on a tangent graph? There is none. So that's actually a dumb question. You never have an amplitude on on tangent. Because there's no higher and lower spot. It's infinity and negative infinity, the way these graphs look. But there is a period. But the period is not 2 pi. The tangent period, you have to memorize that, is pi. And there was no adjustment. If you notice, did any of these have a period adjustment? No. None of them had period adjustments. Be aware you do need to know how to do a period adjustment just none of these three had one. I kind of didn't put one on. Because I wanted each one to do one change only, and period was the one I left off. Okay. Let's draw our midline on. I want our midline be down here. So I'm going to go 1, 2. And I'm going to draw a midline right there. That is the new, basically, are you okay? That's my new x-axis. Can I now draw a tangent graph at that new x-axis? That's what we're doing. Instead of drawing normal tangent and just pushing it down to, can I just create it at that new line? I think that's fairly okay. You can just, kind of ignore the top x-axis for a second. And let's create. Now the problem with this is you have to find your first asymptote. And do you remember how to find that first asymptote on a tangent? It's always half of the period. So if the period's pi, what's half that? Pi over 2. So my first asymptote is going to be at pi over 2. Now the next question then is, where are my other asymptotes going to be? Well, if the period is pi, won't that be where my next asymptote would be? Isn't the period tell you the spacing of your asymptotes? So if this is here, won't your next asymptote be right there, a pi over, a period over? So can you just put another one right there? Can you also do this left? If you're going right pi, can you also go left pi and put the other ones? So hopefully you can see there's another one over here. And another one over here. Now try to ignore the x-axis. We now need to draw a tangent graph. A positive tangent graph. So it's going uphill. Let's draw one of the cycles of it. A tangent graph. Here's kind of what a tangent graph looks like. All right, a tangent graph will hit right here and is going up like that. That's how a tangent graph looks. It always hits the middle of the two asymptotes. But it hits on the midline. Hits the midline, and it always has this up look like that. Looks like an x cubed graph. Y equals x cubed graphs kind of looks very similar to them. And then can you keep doing that over and over between every single asymptote? You just make one and then you replicate it. I think these are actually easier to draw than sines and cosines to some extent, but once you have the asymptotes. So could we do another one? It's going to hit right here in between. Always hits straight between. And we just do another one. Boom. Again, they don't touch the asymptotes. They get really close, but never touching. We get this one right here. Now, aren't these edges a little bit harder? Because I'm only going to do half of it. So can you predict what the half would look like if we kept the same look? Hopefully you can predict, well, this one's going to look like that. And won't this one look like that? And there's our tangent graph. That's now centered right there. It's called the midline. It's the middle of it. Again, I could have graphed this right here and then push it all down, but could you see how messy that would get? If I try to graph it here and then move it, there's so many lines that that shifting would get really ugly. So really the only one you probably want to actually shift would be this one. This one you might want to just draw after it's been moved. Well, you'll see as you get more and more practice. But the key is make sure you know the difference between a sine, cosine, and tangent, what their major basic graph looks like, and then understand how the numbers around them are changing it.